Welcome. We're going to go over questions 155 and 156, so let's do it. Here we go. There are two variables, x and y, that we're being asked to measure for a random sample of 25 subjects. Two separate regression models were fitted to the data. The least squared regression line estimates the parameters in model A yielded the following equation. So here's the equation of the least squared regression line. Notice that they did not graph for us a residual plot of x versus y. So we are to assume maybe that they did see some type of a pattern. Maybe there was a pattern. And so therefore, when we see a pattern in the residual plot, we say a linear model is not appropriate. So again, we're kind of led to assume that they maybe looked at a residual plot of x and y and saw some type of patterning and decided in their mind, you know what, I think a linear model is not appropriate. So when that happens, you can proceed and start doing the log of x or the log of y or both. So it looks like they did both the log of x right there and the log of y, which is totally okay, and they graphed that. And then look, they graphed the residual plot, and that looks like a pattern, a smiley face. So now I could say, aha, well, I believe that a log x log y is not appropriate either because I saw a pattern for the same reason here. So they didn't give up. They kept going, and it looks like third time's a charm. In model B, they went ahead and created the formula for their least squared regression line as log y and x, and it looks like they did not get a pattern. So we have a winner. What can we say about that? We can say, because there is no pattern, that this model would be appropriate. Okay, so now, which one gives us the correct conclusion or summarizes what we just talked about? Model A is appropriate. Well, no, model A is not appropriate because it's got a frown. Model A, not appropriate because we see a pattern. So I'm going to go ahead and cancel out C and D. So I've basically narrowed it down. Why would model B be appropriate? Well, model B is appropriate since the relationship between x and y is linear. Well, hold on a minute. Remember I told you they never really gave us a picture of what x and y is. We're kind of assuming it probably wasn't linear because they didn't use it. They proceeded to try to manipulate the numbers in some way using a function. So this one doesn't sound right. Now let's look at E, which I believe is our answer. Model B is appropriate because the relationship between x and log y is linear, and it does appear that because they graphed x versus log y, x, and they said the response is log y, we don't have a pattern, therefore we can say that that's going to be linear, and this is a usable least squared regression line equation. Now let's go to the next question, 156. Looking at this question, it states a concert hall has 2,000 seats. There are 1,200 seats on the main floor and 800 in the balcony. So it looks like our grand total of seats is 2,000. So the main floor has 1,200. The balcony has 800, and it looks like that's all the chairs. 40% of those in the balcony buy a souvenir program. So it looks like we're going to either decide, did they buy the souvenir program or did they not buy the souvenir program? So it states 40% of the balcony people. So I need to fill in this box with a little bit of math. So they're telling us that 40% of the balcony people bought a program. So this is bought the souvenir program. 40% of the balcony people bought that program. So of means multiply. 0.4 times 800 would equal 320. So we know 320 people, because that's 40% of the balcony people, bought a program. Now they're also telling us that 50% of the main floor people bought a program. So that's a little bit easier math. 50% of the main floor people, so that would be 600. But again, I can write this out. 50% of the main floor people bought a program. So 0.5 times of means multiply. Definitely get that. So we can quantify the total number of people that bought a program and the total number of people that did not buy a program merely using the rules of complement, and just double check our math here, making sure everything adds up appropriately. Now, with my table filled in, I can do the whatever question they might ask. If an audience member is selected at random, so this would just be an audience member, what's the probability that a program was purchased? So it looks like out of all the people in the audience, 920 people bought this souvenir program. And when I crunch the math here, I get 0.46 is the probability, and there's my answer. Thanks for joining us.